Okay, before we do more work on planes in space, we need to make sure we remember how to do some of the linear algebra. They tweaked things a little bit in the textbook and in the curriculum, and so I think you've seen a little bit of this in a two variable, two equation situation, and now we're going to throw it into three variables because now, if you notice, this could be the equation of a plane in space, and so we have three planes. But before I get ahead of myself, what I want to do is we're going to practice doing row operations, and you'll notice I can't type this into my calculator as it is because of this A value. So I've definitely seen problems in IB where they require you to practice to do those row operations, and then we'll talk about the different values of A and what that means for our situation. Okay, so to begin with, we're going to take this set of equations and turn it into a matrix. I typically would draw it this way. Okay, and our goal, if you remember, is to get to the identity matrix, which is this, and then we can have an A, a B, and a C. And so this tells us that our x is equal to A, our y is equal to B, and our z value is equal to C. When I notice all of this first column, the coefficients of x and the coefficients of y is z, and then your constant over here. Okay, so if we get down to this situation and we have an A, B, C, then, well, I don't want to talk about that yet. Okay, I'm getting ahead of myself. Okay, let's see what happened. Let's see. So on this one, my goal is I have a 1 in that particular spot right here. So I'm going to try and get 2 zeros below it. So in general, get a 1, then get the zeros in that row, get a 1, get the zeros in the row. I keep saying row, I mean column. Get a 1, get the zeros in the column, get a 1, get the zeros in the column, and get a 1, get the zeros in the column. And life is better if you do it in that order. Okay, so to begin with, I'm going to keep this top row. And I'm going to say, okay, well, let's say -2 times row 1 plus row 2, and I'm going to replace that with row, and that'll become my new row 2. So -2 is times 1 is -2 plus 2 is 0. That becomes a +4 plus 1 is 5. That becomes a +2 plus 3 is 5. That becomes a +2 plus 13 is 15. Oh, already that makes me happy. Notice how they're all divisible by 5. That's a lot easier. Okay, so in this one, what do I want to do? Let's do row 3 minus row 1. So this minus this. I did that because then I can have a positive value here, but whatever. Okay, 1 minus 1 is 0. 8 minus a -2 is 10. 9 minus a -1 is 10. And then I have A plus 1. Okay, the next thing, my next goal is to get a 1 in this placement. So what I can do, I'm going to just keep everybody everywhere else. And I'm going to divide through, I'm going to say I'm going to take 1/5 of row 2. I'm dividing by 5, I'm multiplying by 1/5. Okay, so that's 0, that's 1, that's 1, that's 3. That's good. Okay, so now I've got my 1, and I need zeros above and below it. So let's keep that row. And then we'll say, well, 2 times row 2 plus row 1. So 2 times 0 is still 0, plus 1 is 1. And that's why we get this 0, so that it doesn't change that value right there. Okay, that's 2 plus -2 is 0. That's 2 minus 1 is 1. That's 6 minus 1 is 5. Okay, and now I want a 0 right in this placement. So I'm going to say -10 times row 2 plus row 3. -10 times 0 is still 0, plus 0 is still 0. So it's so nice to hang on to these zeros. Okay, so -10 plus 10 is 0. -10 plus 10, oh, that's interesting. -10 plus 10 is 0. This becomes -30, right? -30 plus a +1 is a -29. So this becomes A minus 29. And already at this point, when I get down to this and I have 0, 0, 0 equals something, what can happen here is either this becomes true or it's false. Okay, when it's true, then what we're going to find is that we have infinitely many solutions. True gives us infinitely many. And when we get more into planes, you'll understand what's happening. False tells you that there's no solution. Okay, there's nothing that can make that statement true when that's a false statement. There's no solution that'll work. So what we have here is we have, well, 0 equals a minus 29. Well, this will be true if a is equal to 29. All right? When a is equal to 29, I get 0 is equal to 29 minus 29. I get 0 is equal to 0. That gives me a true statement. And so whenever a is equal to 29, I get infinitely many solutions. If a were, so either a will be 29 or it will be anything else. So if a is not equal to 29, if it could be anything else in the whole wide world, then we have no solution. Because we'll have that 0 is equal to not 0. And that is a false statement, which therefore implies that there's no solution. Okay, does that make sense? So what happens here is we have infinitely many solutions when a is equal to 29. We have no solution at all when a is equal to anything else. So let's make sure that you get a chance to practice doing some row operations. I did have a video where I did this with a 2x2. So hopefully you've watched that before you watch this. If not, go do it now. And then watch this again. Good luck to you. Practice, practice, practice.